Welcome everyone to today's webinar. We'll be just starting in next 2 minutes. So today we are going to be looking at how we can predict the prices of our home. So we can do it like our home or anybody's home. So what I have is a data set from a Kaggle. It's a US housing data set. It's very popular data set. It's called the house prices in US. It's on Kaggle.com. So I'm taking that data set. I'm trying to build machine learning models, of course, the data cleaning, the feature engineering, everything with it. So I build the models. In the end, I get the predictions. I do the scoring so that I can get the price of my home, nearby homes, and the other homes. And then I want to be understanding the factors which are leading to increase or decrease in the house prices. So we call this the causal modeling or the explainable AI. So I would want to be focusing on that part so that in the future, a lot of audience today joining us is going to be just the people who buy normal real estate, not anything to do with machine learning. So what I want to be explaining is that how they could do it on their own, and how using those techniques you get the prices of your house. So with that, guys, good afternoon. It's a bright sunny morning. It's 30 degrees Celsius. I am still not good with Fahrenheit. I live in Oklahoma City. My name is Harsh Gupta. I currently work as head of AI at Cliently. And what at Cliently, what we do is we help out marketing and sales teams with AI predictions, machine learning requirements. We set them an infrastructure so that they can have the predictions in their CRM, in their dashboards, and they can get it in a very easy, consumable way. But this webinar has nothing to do with sales and marketing teams. It's just the machine learning webinar. So it's 1 p.m. my time. I'm going to get started. By the way, any questions, any comments, please post them on the chat. I will happily take them after I'm done with the webinar. And please do post the questions, comments, anything you would like to discuss after the webinar. So with that, guys, I'm getting started. I'm sharing my screen. Let me know if there's any audio or video problem anytime during the webinar. Okay, perfect. The topic for today is predicting the home price using no-code AI. A little bit about me. So I've been working roughly 7 to 8 years in machine learning. My first job was working with Grofers. I was doing a lot of work on e-commerce data. Then I started working for WWF. I worked for Johns Hopkins. I've consulted a lot of companies. I was recently consulting Best Buy on their sales forecasting. And right now I work with Cliently, work with many sales and marketing teams. So I want to be talking about, how are we estimating the selling price of the home currently? So right now, if we are not to be using the machine learning, what are we doing today? How are we estimating the selling price? Let's say I just called up my mom yesterday, just before today's webinar, and I asked her, Mom, how do you estimate the price of your house? She says, I look at the comparable properties nearby, and then I can estimate that how much the selling price of my property would be. I said, Mom, is that reliable? How can you, people will have different numbers. It's not scientific. She said, to double check, I'll go to the realtors. I'll ask the neighbors just to be double sure of the numbers. I said, okay, that's still a better way than just guessing from the neighbor's estimate. But is that 100%? Like a realtor will have a better idea than my mom, but he or she will not be 100% correct. So then I said, Mom, what do you do next? Mom said, okay, then I'll pay the assessors. They'll come, they'll do the calculations, they'll come up with a number. Uh, okay, that seems better, but it involves a lot of cost, as well as it's not like 100% scientific, right? You don't have the tons and tons. The assessor is not assessing the tons and tons of data. He has a better idea for sure, but not assessing or not doing machine learning. And then ultimately, I had this in mind. My mom didn't know it, that you could also try websites like Zillow, where you put out your property and you get out an estimate of your home price. That is actually an excellent way to get a pricing. If you're in India, it's housing.com. If you're in US, it's zillow.com. Guys, can you hear my voice? Is my voice audible? Because somebody wrote that my voice is not too clear. Can more guys comment if it's good, bad? I'll resume if it's good. I can hear you fine. Okay, perfect. Thank you, guys. So going back to this one. So if you're in US, you can use websites like Zillow. If in India, you can use housing.com. And I'm sure every region has a different website. So now that brought me to this topic, that can I add more science to this whole process? Okay, and this is I'm a machine learning engineer. I've always done machine learning, so I decided to take the data set and see how good I can accurately predict. So using machine learning, we can predict with a very good accuracy, usually 80%, 90% accuracies, because you have. So even if you take the housing data set that I'm going to just show you in a while, that has like 81 variables. So the accuracy is going to be so high. And then using the interpretability AI, or I like to call them causal modeling, we can understand the drivers behind the higher price, so that next time, if I'm going out in the market to buy something, I know what to look for, so that tomorrow or some years from now, I can sell my price at a better price, at a higher price. So once I understand the factors, understand the drivers, I'll be able to do that, right? So this is what we'll be doing in the later part of the webinar, understanding the factors that drive the price. And then further, can I get the answer to this question, when should I be selling the home? So this third part I'm not covering in this webinar, but it's of very relevance, because I can easily do a I can easily do a home forecasting, home price forecasting. And then there are various time series techniques I can use at. And then I can tell, okay, 2022 quarter 4 looks like the best time to sell the house. So quick overview of machine learning process before I jump onto the actual process. We download the data set of various fields associated with house. We take the latest information. So this data set on Kaggle, my guess is it's somewhere between 2 to 5 years old. They haven't given the dates. So you would want to take the latest information, and then you clean the data, you prepare it for the modeling, you do feature engineering, which means adding more features to the current number of variables. And then you build a lot of AI models. Usually the tree-based models are the winner models, like Random Forest, CatBoost, like GVM. Those are the winner models. You could also use a combination of them, ensembles. And in ensembles, it would be stacking and blending. And then you tune the parameters of every model. So the way to understand tuning, hyper-tuning parameter is that, think of it. Let's say I'm at the radio and the 93 point frequency is the best frequency where I get the best voice of a certain channel. So I have to adjust, like maybe 93.489 is where I get the best audio. Maybe 93.50008 is the best where I get the best voice. So that is like with the models, you hyper tune the parameters to see like, okay, this is where I get the best accuracy on this model. So you can use Bayesian search optimization, random grid, but I'm not going to go into technicalities. This is a very non-technical kind of a webinar. But if you want to know more, like shoot me an email, I'll be happy to help. And then after this, you've done the model building, then you would want to understand the drivers behind the selling price, predict your home price, as well as you want to decide when do you want to sell the house. So this is the data set. It's on Kaggle.com. It's called the Housing Prices Advanced Regression Techniques, and it is coming under many names because a lot of people have put this data set. So it's a very popular data set. Now let me show you the data set in the Excel file. This is what it looks like. There are ID, there is lot frontage, lot area, street, alley, lot shape. Just there are 81 variables associated with it. And in the end, I have the sale price of the house. It's in dollars, and I have roughly 1,461 houses. Okay, cool. So what do I do next? So normally, what you would do is, and I'll share the code at the end of the webinar. So normally, what you would do is, you would run the data set in Python. You would do some quick exploratory analysis to see how your data set looks like. And then you would clean the data, you would build feature engineering, some model building, train, test, plate, etc., etc. So I have the models, I've done some model building, and I'll share it with you. But this requires a lot of coding, right? As well as this is not 100%. I've missed out on data cleaning, feature engineering. So instead, what I'm going to be today using is our own platform. It's called Proton AutoML, the software that we use to do machine learning predictions, no code machine learning predictions actually. So what I'll essentially do is I'm just going to pass the data set through this platform. I'm going to create a report. I'm going to call it Housing 3. I'm going to use a data connection. Just upload the housing data set. Next. So then it will ask me, okay, what do you want to predict? What is the ID? I will tell the system what is the ID, what is the target. It takes some time because the data set is big. So I ran this a few minutes ago. I'll just come to it once I define the target and the ID. Okay, never mind this. Yeah, so this is what the data set looks like. What I'll have to do is I'll just select the sale price. This is what I want to be predicting and my ID, and then I'm going to click on the start analysis. So the report will be running in the backend. So what I'll have is, I just ran it a few minutes ago, 1,460 observations, 81 variables. If I just check the logs quick, it is taking care of all the machine learning for me. It is cleaning the data, it is building the features, it's then building the models, it's doing everything possible. So I don't have to write any code. Good part, yeah. Now I want to be looking at the predictions. So we have two kind of reports, one which focuses on the explainability and the other focuses on the accuracy. So I want to be looking at the accuracy part first. So I built models considering accuracy in mind, and I got an RMAC of 15,812, which is pretty good, and an accuracy of 92%. That means that all the input variables of mine are able to explain the predictions 92% of the times. Now I want to be looking at this variable. So if you look at the predicted, which is what we are predicting, and blue is the actual. So if you look at this, we divided them into decile and we took an average of them. So our predictions are off at the top of the deciles, meaning if I sort the houses by the highest to lowest prices, for the prices in the top 10% of the data set, the sale price, our predictions are a little bit off, not much, a little bit off in the first decile and the second decile. But then as we move down, our predictions are accurate. And then at the very bottom, when the prices are the lowest, then our predictions are a little bit off. So for example, look at the decile 9. The mean values per decile are 112K. We are predicting 122K. So the predictions are a little off at the very top and at the very bottom. Okay, so what do I do next? So I've got the model. I have the accuracy. And this is what it looks like. So for example, serial number 893, the actual value is $154,500. and we are saying it's $145,000. So we are off by $10,000. In this case, we are saying $278,000, but the predicted was $274,000. So as you know, machine learning is never going to be 100% accurate, but it's pretty spot on if you think about it. Like most of the predictions are pretty right. So what do I do next? So now what I want to be doing is I want to be doing a scoring. So let me show you the scoring data set. So remember the training data set had the sale price of every house. But now this one, for this data set, I do not have the selling price of the house. So what I'm going to be doing is we call this scoring or even deployment. So I'll take this data set, I'll pass it through the model builds already, and then I'll get the values from the models learned the best behavior, they classified into everything, and then they're going to come up with the values for everybody. Now remember, this data set didn't have any selling price. So now I'm going to download this one, and now I have the selling price of every house. By the way, this one was a house that I came up with. So all the values that you're seeing, I came up with these values. It wasn't in the original data set, completely new values. So I wanted to see what the selling price of the house would be. So I'm just going to do a copy paste here. Perfect. And now I'm going to round it off. I'm going to put a dollar sign. Okay. Perfect. So now I have the predicted values for the new houses. So imagine if if the first one was my house, I would have been selling it for $126,000. Now I know that doesn't look good, but it's a made-up data set. So that's why the values are looking much lesser. However, inflation, the prices are skyrocketing. So now I have the values. So what next can I do possibly after this? So now, let me go back to that question, and the question was that using interpretability AI, I want to understand that what is driving the prices of the homes, what is causing them to go down, what is causing them to go up. So now I want to be using a second. So we have two types of pipeline. One we use for the explainability, one we use for the accuracy. Sorry, this one for the accuracy. So now I want to be using this one for the analysis, explainability. And let's look at the variable. We call them global explanations. So this is the summary, and these are the variables which are super important. So let me zoom in if you cannot see. So if I look at the variable overall quality is the most important variable in deciding the price of the house. Okay, then comes the pricing called, then comes the variable called the GR living area. I'm guessing it's the greater living area. Don't know what that means. Then the model was added. The total basement in square feet, the garage cars, the basement in square feet one. So the variables are ranked, and the higher the ranking of the variable, the more it is a deciding factor in housing price. Now that does not mean if the variable is on the higher rank, it means the price of the house goes up. It just means it helps in deciding the price of the house. But okay, how do I know that if overall quality goes up or goes down, the price of my house goes up or goes down? Okay, so let's look at this one, overall quality. So overall quality, let me first jump onto that variable, what variable it looks like overall. Okay, so this is a variable and it ranges from 1 to 10. Okay, perfect. So what it is telling me is that when the values of the overall quality are between 1 to 5.5, the prices of the house tend to go down. They tend to be on the lower end. But as soon as the value of the overall quality starts going up, the 5.5, the prices are going up, and then see the prices are going up in a very ladder like formation. So at this one, 8.5. At 9.5, it stabilizes. From 9.5 to 10, it doesn't influence. Like just from look at from 5.5 to 9.5, the values are going up. So that is a good thing. So overall quality, if it increases, the price of my house also goes up. Uh, After 5.5, if it's 0 to 5.5, it's not determining the pricing of my house. Okay, so now I want to be looking at some of the other variables. So for example, great living area, year, model added. Okay, now look at this one. So what I'm looking at is as the GR living area is from value 912 to this point. Yeah, so from there it starts increasing. Actually, this point starts increasing. So there are lines here actually from this point from 912 to the 1039. It doesn't affect the housing price, but as I go up, it just slightly increases the housing price. Overall, it increases the housing price as I go up, and from this point suddenly there is a higher jump in the housing price from when the GR living area is equal to from 70 1798 onwards, suddenly goes up. Now let's look at another variable, neighborhood. Interesting. So when my neighborhood is Edwards, the pricing of my house went down. Okay, interesting. When my neighborhood is Gilbert, the pricing of my house went down, but not as much. When it was Edwards, it went down a lot more. When my neighborhood was blue BLMNGTN, it didn't have any effect on the housing prices, negligible effect on the housing prices. And now let's look at this one. Suddenly when I'm looking at the if my house is in No Ridge, the value of the house goes up so much by a unit of 20,000 just by being in the No Bridge. Old Town, the value of my house went down by $5,000. So now I can estimate that, okay, these are the variables which are influencing the pricing of the house, which I put it in the summary. And then I can dig into every variable that, okay, how does in changing the variable affect the housing price? So this is what I call the global explanation. Now remember, next time you're buying a house, just let me know you're buying a house. We can go through it and we can understand that what is the right price you're paying for the house and what are the factors. Okay, so now I want to be going at the local explanations. Give me 30 seconds. So this is something super important. Let's say I'm choosing the first house, right? And let me show you the first house. So this was a housing data set. This was the first house. And it had a value of 208,500. Okay. So I'm looking at this one, the actual, see, $208,000. We predicted it to be $188,000. So our predictions are a little off here. And what we are saying is, like super important, please note, please be watchful that the variables in the orange are causing the price of the house to go up. Okay, the orange variables are positive indication of the house price. The blue variables are causing the price of my house to go down. Ignore the word intercept. It doesn't count here. So what is happening is this house was year model added 2003. It had a value of 2003. So this one is causing the price of the house to go up. The overall quality, remember 7 was a good sign. So this makes the price of the house go up. Total MSA, BVGRD, whatever that is, causing the price of the house to go up. But now I look at this variable, the total basement square feet. This is low compared to the average, and that is causing the price of the house to go down. But overall, if you see, because the orange variables are more, so overall the house has a higher price than the average. So I can understand that every house. So let's say if it was your house, I could just bring it here, right here, and I could be seeing that, okay, year construction 2003 is a good indication that is going to get you a good price. But your basement is on the lower side. The area of the basement is low, so that is causing the price to go down. So you can exactly get an idea that what is causing the price to go up or down for every house, and what exactly is the reason behind that pricing of the house. This was on a global scale for everything. This is on a very local level, on a very house by house level. Okay. Now I want to show you something interesting. So I call this the what if else scenarios. Okay. So what I want to be looking at is okay, I'm fine with this overall quality. So these are all the plots plotted on this graph. And I'm just going to click on something like this one. Okay, I clicked on this one. It says row number 246. The true value is $165,000. Look, the value of your house is $165,000. And the predicted value, our systems, our algorithms gave it a value of $160,000. Actually, $146,000. So now what I want to be doing is, okay, let's say if I move my neighborhood from names to Edwards, what would have been my new predicted house price? Okay, so I just changed the value here. Now what I'm going to be seeing is new predicted value. So when I changed my neighborhood from whatever that previously was to now Edwards, suddenly my house price dipped by $3,000. Right? So we call this the what if else scenario. So for example, the full bath is one. Right now this house has only one bathroom. Now let's say I want to construct two bathrooms, and I want to get an idea that if I make it two bathrooms, will I get more pricing on the house later on in the future? Let's try that. Save as a new point. So suddenly the price went up when I made it a full bathroom. So before it was $157,000. So suddenly I made another bathroom in my house, and the value went up by $7,000. So this is what I like to call the what if else scenarios. It's like must have seen the Marvel. What is the name of that series that recently came out in the Marvel? What if? Like what would have happened in a different universe if this had happened? So it's kind of that. What would have happened if you had changed one of these values? The universe is the same. It's just to get an idea of your data set. So this is the explainable AI part. Now back to the presentation. Looked at the key drivers. Okay, another thing I want to show you is the chat plots. We've covered this a lot already, but just to give you a quick idea, like these variables are listed. The one which are the red means the value goes up. The ones which are the blue means they are causing your housing price to go down. So in this case, the overall quality, as the value of the overall quality increases, the value of the house also increases. So we call these as sharp plots. Okay, we did score the new customers as well. Okay, so now almost done with the webinar, guys. A couple of last things. So some more accommodations that could have been made. We could have only considered the very recent houses that were sold, because especially in the last 1 year, you see it in the news everywhere. Inflation skyrocketing, the prices going up. So you would want the latest data to be absolutely sure. Updated selling price according to inflation. You could also take this as a forecasting problem, time series problem, a lot of algorithms, ARIMA. There's just so many options when you're doing time series. So with that, guys, I'm going to open this up for questions, comments, and let me also share the PowerPoint presentation with you so that you can download it, have a look at it later on. Copy link. Yes, I'm recording the session. So I'll be sharing this with everyone. So I've recorded this webinar. I'll be putting up on the YouTube. Please watch out for our YouTube channel. It's called Cliently, YouTube Cliently. So we'll be posting it out on there. You can have a look. So with that, guys, I'm going to take up questions, comments, discussions you would want to have. Also, if you think you want to do AI predictions and you don't have a team of engineers, data scientists, I'm happy to help you. I'm happy to have give you access to this no code AI platform where you could literally predict anything all at one click. You just upload the data set, you get the predicted values, also get a lot of explainable AI dashboards. So you can reach out to me on LinkedIn. My name LinkedIn Harsh Gupta 04. I'm also leaving out my email address if you want to reach out to me afterwards. I'm happy to have those discussions. Anything you would like to predict. So the name of the platform is so our company acquired Proton AutoML. The machine learning platform is called Proton AutoML. And to use it, you'll have to run through one of our executives, one of our account executives, and then they'll be able to give you access to it. Without them, you won't have the access to it. It's a closed software. Okay, so I'm starting to take the questions now. Okay, glad my voice was good. Same here, cannot hear. Okay, some people had problem hearing me. Okay, I hope the recording has a better voice. What is the name of the platform? Is it? Do we have to use any case dataset preloaded? So there are already preloaded datasets in the software, as well as you can download from anywhere, or you could connect to your Salesforce CRM. Just it's like a Tableau. You can connect to anything, anywhere, and it has preloaded datasets in it. Is it work with time series as well? Yes. So there's an option for us to do time series in our software, and the clients which are using our software, they have the option to use time series as well in the software. But for the simplicity of this webinar, I haven't done time series because it would have involved another half an hour. And I was just reading somewhere very interesting that people like to come onto the webinar just for half an hour. So I didn't want the webinar to be 1 hour and then people leaving the webinar. But next time, yes, that's a great idea. Next time, I'll be taking up the time series. Do follow our page Cliently on the LinkedIn. We post weekly webinars. So hopefully, in next 3 to 4 weeks, we'll have a webinar on the time series as well. Can I please get the Python code? Okay, sure. So what I'll do is I have everybody's email recorded. Sai, I have your name. I'm putting it down. I'll share the code with you. But the code is not exhaustive, by the way. The code is a very simple code just to show it. It just brings in the data set. It just builds model. That's all. No cleaning, no feature engineering because I didn't have the time to write the full code. What is the fee for the software? So it depends. It's a very custom pricing. But if you want to discuss the pricing, I'm not the right guy. You would have to discuss with our account executives or sales executives, and they'll be able to understand your requirements and get you the best pricing. So again, Rupesh, you can reach out to me on my email, harsh@cliently.com. You can shoot me an email and I can forward your email to our executives and they can take it from there. Unfortunately, I'm a very bad salesman, so I've stopped selling anything. I don't do anything. Okay, me too for the code. Okay, I have your name as well. Perfect, I'll be sending you out. If your emails entered are correct, then you'll get the code from my side. How to get in touch with them? Um, just shoot me an email on harsh@cliently.com and I will forward your email to them and then they will reach out to you. So that would be the best thing. Give me 1 minute, guys. Guys, any questions that you have? Anything you want to discuss about data set? I'm also interested how you are predicting your home price when you go to buy a house. How do you do it? Do you use Zillow? I've heard most of the people use Zillow. Is it true? So do let me know what you guys think on that one. Can we mix it with the AWS ML as well? Pawan, no. Right now, we don't provide that option. However, in the future, what we are going to be doing is we are going to be mixing it with AWS SageMaker. So platforms like Google AutoML, Data Robot, AWS SageMaker. There are a few platforms. They don't do a good work in data cleaning, feature engineering. So we realize that value, and we are establishing a partnership with them. And in our partnership, what it would look like is we clean the data, we do the feature engineering, and then we use their algorithms to build the machine learning models. Although our algorithms are also very good, but since people would want to use a hybrid, so we are trying to make it available, but we don't have that option right now. But I'm curious, why do you want to mix it up with AWS ML when you're getting predictions, like end-to-end predictions at one platform? Just curious. How is it different than PiCarrot? So Nikhil, PiCarrot is an open source library, right? You call it, it builds machine learning models, and it's great if you're good with Python, if you know your work. But the only problem with the PiCarrot is, now that's a blessing in disguise. That's a blessing as well. So the only problem, I've used PiCarrot, it does not clean the data for me. It does not do any feature engineering for me. For example, if there is a date variable, it will not do anything with it. It will just, and the machine learning models do not understand the date column, right? If the date column is like 0301 2021 000024 AM, you have to clean the data yourself. You have to break it down into month, into day, into year, into the time, into hour, minutes, seconds, the AM, PM thing. And then you have to bring all those values to the machine learning algorithms. What we are good at is doing it ourselves. Our code automatically does it for the people who are super busy, who are the executives. Now, if you want to clean the data yourself, then absolutely our platform does not make sense for you. Why invest dollars in our platform when you clean the data, when you do the feature engineering yourself? Then there's no requirement. PiCarrot is good for you. But if you're an executive, or if you're a data BI analyst, or some sort of a data professional who's short on time, who wants to do a lot of projects, then our platform makes sense because you're paying dollars for it. PiCarrot is free. So that's the difference between PiCarrot and us. It's not comparable. It's a completely different thing. Ours is a completely different thing. But if you're a data scientist, PiCarrot is good because it builds model in 1 or 2 lines of code. But remember, it's not doing data cleaning, feature engineering for you. It does some basic like outliers, standardization, normalization. But if there's an address column, 1400 20th Street Northwest 416 Washington DC 20036, it won't do anything with it, and it won't pass through the machine learning model. It's useless to the machine learning models. But we break it down: apartment number, building number, street number, street name, city, state, country. We do all that. So that is where you pay a premium for it, right? Our code is doing so much, and hence you pay a price for it. So that is it. There's another question. Just give me 30 seconds. How did you get the information on neighborhood and whether it's a high selling one as important variable in prediction? So the data set was already there, right? It pre-existed in Kaggle. Kaggle got it from some USA. Somebody actually, not Kaggle. Somebody in Kaggle got it from some of the government websites. And now when I didn't define system anything. I didn't say that, look, neighborhood is an important variable. It just happened that it came out to be the fourth or the fifth most important variable. So that is a good part about machine learning. It automatically finds out which variables are important. And then I further was able to dig into that variable and find out which neighborhood leads to increase in price and which neighborhood leads to decrease in price. We call that AI explainability, explaining the black box model. So that is how I was able to get it. Anything not clear? Please, if you want to clear up, because I think I answered that one. Okay, guys, waiting for the questions that you guys have. Happy to have the questions, comments. Even just let me know what you think on uh, just simply the predictions. Okay, sure. You're welcome. Some other questions are coming up. By the way, guys, I'm curious. What is like just some survey? Is this a good time for you to have the webinar? Like for me, it's 1 p.m. It's 11 a.m. Pacific time. It's 2 p.m. Eastern time. So the time is good, right? You guys think so, or should we schedule before or later on? Just happy to have the discussions or a kind of a survey. We should have used a form and then should have done some machine learning on the form to get the insights. That would have been interesting. I was doing this. NPS survey. So NPS is kind of a feedback that you take from the clients to understand where they are in the stage, what their sentiment looks like. So I remember yesterday I was working on this NPS survey feedback form, and this client of ours had sent the form to roughly 4,700 people. And much of the forms, many of the questions in that form were unfilled. People had not marked anything. So I was using this technique called double standardization, which we use in the survey forms to guess the values of the missing values. So very interesting thing I was doing yesterday. Why am I mentioning it now? Because machine learning is not just about building algorithms. As somebody pointed out, like why not use PiCarrot? Because it's not about just building machine learning models, right? And it will never be. You build all the models, you get the answer. It will never be like that. A bad input will create a bad output. And why that happens? That happens because if you're not the raw variables are often in a bad manner, in a bad shape from CRM systems. For example, survey form, right? Many missing values. Now, if you bring that to machine learning model, okay, maybe the cat boost will do something, but still it won't be a good imputation. So you want to be understanding the data, and then you want to be doing the data cleaning, the feature engineering accordingly. Um, so it is very important that you understand the nuances in the machine learning. I can understand that a lot of audience today are non-machine learning engineers. Like most of the time, half our audience is non-machine learning engineers. So those are the parts to machine learning which the non-data scientists do not understand. And just showing an example that how important is the data cleaning, the feature engineering part. Okay, guys, any question, please shoot me, else we'll have the webinar off. So taking the question, you can make the blank in the form mandatory to fill form. Yes, the client didn't do that. They thought that if they make it mandatory, people will altogether opt out of the form. So they were asking 20 questions, and they thought that if they make all the 20 questions mandatory, people may fill the wrong values either, or people may altogether abandon the form. And it happens, like if somebody sends me a survey feedback form, I start filling it, and it continues asking. I'm like, leave. I'm not filling the form. So that was the case with them. So a lot of missing values, and that's part of machine learning, right? That's you have to solve those problems. Even even in the survey forms, a lot of people fill the wrong information. It's if you're doing machine learning, it's your part to figure out that okay, people are filling the wrong information, because how can for the question one, the option B can repeat 90% of the times because it was the very first thing. So now you know, okay, people are filling the wrong, and if it's persisting with 4,700 people, there's something wrong. So there are ways to address that as well. I highly recommend a paper. It was written many years ago by SAS, uh, Double Standardization Survey by Gautam Chakrabarti. I don't remember the name. I read it, I learned from it, and I've been implementing it since then. Okay, guys, with that, I would like to say thank you very much. Thanks for coming on our webinar. Do follow our page cliently. there's a next week webinar on fraud investigation, that how you can detect fraudulent transactions in your data set and what you can do about it. So I'm going to be looking at that one. Thank you, Huda. Thanks for attending. Yes, using machine learning. I'm a data scientist. I never do anything which is not done by machine learning. But again, it's going to be a no code machine learning. So I'm not going to be showing the machine learning code and explaining the machine learning part, because that part I already know that a lot of people are literate. Our goal, our objective is to teach people how to use machine learning in day-to-day applications, as well as to the data scientists that how they can do better, how they can make executive recommendations, executive strategies. So thank you guys for attending. Hope you have a wonderful day.